Hey everybody, today we're learning about chemical equations, which means representing chemical reactions with chemical formulas and arrow. Chemical formulas are the symbols for elements and subscripts to represent how many there are. For example, water decomposes into H2 and O2. The reactants in this reaction are the things that are reacting, the things that you start with. That's everything on the left side of the arrow. In this case, it's H2O, water. And the products are the things that are being produced. In this case, it's H2O2. And in general, it's everything on the right side of the arrow. So we'll notice a couple of things about this equation. First of all, notice that if you reverse it, you still get a reasonable equation, a chemical reaction that actually happens. The first one in blue takes energy to occur. The second one in black releases energy when it occurs because they're reverse reactions. The second one is combustion reacting with O2. The first one you would call decomposition. You do it by putting electricity in, so that's also called electrolysis. And when we switch it around, then now H2 and O2 are the reactants, and H2O is now the product. So whatever's on the left of the arrow, these or these, that's the reactants. Whatever's on the right, that's the products. Another thing to notice about this is that in both reactions that I wrote, the blue and the black one, H2 and O2, hydrogen and oxygen, even though it seems like they would just be H and O, those are written in twos, because they're so stable together that they always come together, almost always. Those are examples of diatomic elements. And here they are: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And then you'll notice that I wrote it that way on purpose. Before we go on a little bit about that, look at the periodic table, please. You can see that these ones going across, starting with nitrogen, then go down, they kind of form a number 7, so that helps you remember there's 7 of them to memorize. There's these 6, and then the 7th one is hydrogen. Another way that we can remember it is by making up a word for it, like Hunkelbrief or Hofbrinkel, that has all of them in it, and then you can just remember that word. If you remind me, we'll sing a song about it tomorrow. Okay, example. Carbon reacts with oxygen. So you write carbon, and you write oxygen. But when you write oxygen, you have to think to yourself, oh, I memorized that's one of those diatomic elements, so I'll write O2. So that's the important thing about this, is when you're writing equations, to remember if it's one of these, it comes in twos. So you write C plus, that's the width, O2, and then those are the reactants, so then you're going to put an arrow, and then you probably know from burning wood that this makes carbon dioxide. You'll notice that these ones up here, this one I've highlighted, and the other one, those are not balanced equations. What I mean by that is that there's an extra O over here that just popped out of nowhere, so that obviously is not what's happening in real life. So we need to show what's happening in real life. The way you do that is you change the coefficients. So we'll put coefficients, big numbers, in front there. Don't ever change the subscripts. And then you can always check at the end to make sure it's balanced. So 4 hydrogens, the 2 multiplies by everything after it. 4 hydrogens over here also. 2 oxygens, 2 times 1 is 2, and 2 oxygens over here also. So steps: never change subscripts when you're balancing, because that changes what chemical it is. If I try to balance this one, for example, by putting H2O2 here, then this is no longer water. That would be hydrogen peroxide, so that's not what you're trying to represent. Balance polyatomic ions first, and just balance them as a whole group is a good way to do it. So if you see a sulfate on one side, then balance whole sulfate together on the other side, so you're not balancing each atom separately. Balance hydrogen, H2O, and oxygen last is a useful rule. Usually helps you, but not a big deal, especially if you do oxygen last, because it's usually in the most places. So if you balance it first, you'll have to go back and balance it again. For example, CH4 reacts with oxygen. So I'm going to write CH4, and when I get to the oxygen, I'm going to remember to write O2. So CH4 plus O2, because oxygen is diatomic. And then arrow to represent the end of the reactants. Figure out the products. I'll have this on the next slide also, but when carbon burns, it makes CO2, like we already learned. When hydrogen burns, it makes H2O, kind of like we already learned here. So when you have both in a compound, you get both CO2 and H2O, but you're not done yet. You got to balance it. So one carbon, that's good. I'm going to save oxygens for last. It's in the most places. 4 hydrogens, 2 hydrogens. So I'm going to put a 2. And oxygens, I have 2 on the left side. You have to count all of them on each side. On the right side, I have 2 plus. 2 times 1 is 2, so 2 plus 2 is 4. Here I only have 2, so I will add a 2 there. So now it's balanced. Okay, a couple of other examples about writing combustion reactions. Combustion reactions means reacting with O2. You see a plus O2 on the left, and it's a reactant on the left side of the arrow. So if you're reacting carbon, we already mentioned it makes CO2. If you're reacting hydrogen, we already mentioned it makes H2O. Then you would balance it like so. If a compound has carbon and hydrogen, it makes both CO2 and H2O. And so really the only new one, I guess, is a metal. If you burn a metal, and if you remind me, I'll show you burning magnesium, you get a metal oxide. So we're going to write MgO, but then that's not necessarily the formula. We've got to check the charges and cross the subscripts to write the correct formula for magnesium oxide. So write MgO. Mg is plus 2, and O is minus 2. So we do have the correct formula. This would be Mg2O2, but you always reduce ionic formulas, so it's just MgO. But maybe make a little note to yourself that we did check the charges here. You can't just put the O and have it always be right. Okay, so if we balance, we have 2 oxygens here, only 1 here, so I've got to put a 2 there. But now I have 2 magnesiums, only 1 there, so I've got to put a 2 there. That's all there is to it. Don't change subscripts. Try to go in a logical order. Check your work at the end, and everything's good.